and y'all hear me. And I'll post this everywhere on Odyssey and let's go to X. All right. Where else are we going? We're going BitChute. Okay, Odyssey, BitChute, Rumble. I haven't got to go Rumble. All right, guys. Anyways, sorry I'm a few minutes late. I was just setting up my Tesla coil, and I have that set up at the ground there. And I also have that Faraday cage thingy. Actually, it's a pet fence. I'll get the Faraday cage fully made. Today, I just want to test out how well this pet fence does. Anyways, we have one person in the stream. It's probably just me. Anyways, I'm just gonna drink my coffee. All right. Why is this logo shown there? That's interesting. It's got my giant logo on this thing. Yes, I see the audio is. We have one person in the stream. It's probably just me. All right. Anyways, guys. Go back in. Okay, I'm gonna open up some stuff. Yeah, we'll go over radio waves and any other technical science questions you guys have, and so on. Okay, now okay, so apparently it's so he's 1 hour ahead now. Okay, that's gonna be a bit wild. Archive. Oh, jet fuel hoax. Yeah, I don't know. All these like everything's fake thingy. It's weird, and also has Space Busters, but Space Busters a flat earther, so that's a bit wild. It's like just can anybody get on the right page, on the same page? Anyways, I just finished my coffee. Anyways, so can you all hear me? Anybody else in the show? Otherwise, I'll take my sweet time, and so on. And the other thing I was gonna go, because that's this one. I gotta go the in Leo threadcast. Get the threadcast ready. And so on. Guess what are radio waves? How come this updates? When you make one mistake, it's done. So it's another threadcast. I updated. I edited it. Didn't work. Anyways, live update. Okay, so we're back in. All right. So we have a whole bunch of stuff to cover. Radio waves and a whole bunch of other stuff. See what my notes says. Okay, I'm gonna go over first a bunch of messages from this guy. This guy on yeah, and also hope you guys like the live stream on the one with John and Nancy Hutchinson. That was quite wild. All right. Okay. Let's see here. Okay, so greetings, stuff. Just a couple things. First, would it be worthwhile at all that I re-upload your stuff to Hive's 3Speak? I have to re-listen to your live stream deep dive anyway. In your 30th MES live stream at 1 hour 46, a guy being interviewed says that there are at least 119 victims so far. Yeah, on 9/11. Yeah, that is very interesting. All. Just trying to drink stuff. All right, get some water in. Also, just today, driving by one of these places, I noticed the Hilton hotel logo is the towers. Not surprising because of the Millennium Hilton being the monolith. And the prime witness of the 9/11 ritual. I'm sure the hotel was packed with high-level Freemasons watching the whole thing. Maybe even Diddy partying meanwhile. Also, in 2001 Space Odyssey, the monolith is 11 feet tall. This was mentioned by William Ramsey. I think this is in his book 9/11 Alistair Crowley, Prophet of Evil. He was interviewed by Mr. Hampton. Have a great day. Yeah, definitely. He was on there. That was in 9/11 Alchemy. And I'll say right here. Yeah, for sure. Yeah, upload anything and everything to Hive 3Speak. I try to upload all of my videos on 3Speak as well. Okay, there is the let's go to 3Speak MES. And I also got my cousin Eyes watching the post as well. Yeah, so I post all the videos and live streams. Videos and live streams. Yeah, I'll say feel free to re-upload or slash clip shorter clips, etc. and upload I will upload your content so you can earn crypto. And then this is Missy Bazaar is also pretty big on 3Speak now. So I got her posting, and let's see what she's at. Let's see, it's worth $2.69, but she hasn't powered up yet. I mean, hasn't claimed rewards 7 days ago, so she can claim again. And so she's on. I think this was where's the 3Speak videos. But yeah, I think in time she'll do really well. Where's the I'll post. I think she's posting. Okay, there's 3Speak. Yes, it's your 3Speak channel. Feel like Mystic Bazaar is on. Yeah. Mystic Bazaar is on it too. Okay, so she's doing it too, and then he says some other stuff. Millennium Hilton. Yeah, Millennium Hilton is definitely I have a post about that. Hilton. Let's see, I think I put. Oh yeah, bizarre effects of the Millennium Hilton on 9/11 as the bottom outer glass panes appear to have been selectively removed somehow. Also, the Millennium Hilton stood right beside the Twin Towers on 9/11 and looked like the black monolith from Arthur C. Clarke and Stanley Kubrick's 1968 film 2001: A Space Odyssey. The film was released in 1968, the same year the WTC construction began. And on 9/11, 2001, Tammy Michael states that her phone number inside the Millennium Hilton is 212-693-2001. In fact, the Millennium Hilton still has a number on their contact us page. And since year one is the start of the calendar, it means that 2001 is the start of the new millennium. Yeah, so big things happen. Yep. Yeah, and there's the
flames are coming out.
And yeah, she says the number here.
Flames are coming out the window. We've been told to stay in our hotel, and I'm watching this right in front of me. I wanted to call and tell you. I'm at the Millennium Hotel. My phone number here is 212-693-2001. Flames are coming out the window.
No, Tammy says still struggle 3Speak. Yeah, what's the issue? Well, you need an email to they need email as well. They need to connect your Hive account. So well, if you want, just send me a bunch of screenshots on Telegram, and then I'll go through each one. I'll tell you what's the issue. So basically, go try to do it, and then anytime you're stuck, send a screenshot, and I'll just see how I can troubleshoot it. All right, so and yeah, yep, the Hilton is wild. I made a post about it. Their contact number has 2001 in it. Yeah, and also, yeah, the 11 feet tall. Yeah, that was part of the alchemy. 9/11 alchemy peak 9/1. And then where's the feature documentary? 9/11 alchemy. Yeah, I'll put the new YouTube one. And yep, William Ramsey mentioned it in Chris Hampton's documentary. Also, this guy talked about the high possibility of Barbara Bush being an illegitimate offspring of Crowley, making Bush the kid Crowley's grandson, reading the pet goat upside down at the beginning of the 9/11 mega ritual dedicated to Crowley. You know, your typical occult BS mumbo jumbo. Yeah, that definitely. And then it says, sad still shows how tough airliners are. God bless. And yeah, UPS 2976, and that's also how many people allegedly died on 9/11. I'll check the numbers. I'm gonna quickly change into some shorts because I'm drinking some hot water. It's hot lemon water. It's a bit hot in here. All right. All right, I'm back. I'll put the headphones on. All right, so yeah, anyways, I'll be using this, we don't have that much people in the stream, so I'll just keep going through messages that I got. Okay, and then this guy right here, yeah, so anyways, he sent this link here. This is a recent one. This is pretty wild, actually. This is, see this airline. Okay, that's not even noticed in the show. Let's go. What you really log in. I thought I unlogged in. What is going on here? So I have to view it in the app. Like Instagram is just trash. Like what's the point of? Okay, this is the. I'll just go here. Uh, let's go. Crash. Kentucky Crash. I'll go on Twitter. Kentucky Crash. Okay, this is right here, and notice how there's like a stream of flames. Okay, is there any other footage of it? Is that the only one? Oh, here's dash cam footage. They're like just bigger. Like, what's the issue with this? Like, is everything just the worst? Okay, let's see. This is. Oh, it goes like that. Okay. Is there some better?
Bro, get the fuck away from here, like turn around. Bro, no, hold on. I think it's gonna crash, bro. Holy shit! Holy shit!
Okay.
Bro!
Yeah, that is I think that's other people posted as well on here. I'll just post go in the chat. Actually, I'll keep this open. I'll leave this here and I'll open up this new tab and we'll do this setup like this. Yeah, so we got jet fuel hoax people. It's like I don't know, man. I don't know. Anyways, that's all bananas. No, good evening and epic stuff here. Yeah, so here's a question, guys. Who are you guys all voting for? Freemason 1 or Freemason 2? I voted for Kodos or whatever. So this is the oh yes, apparently Dick Cheney died yesterday. And then this was flight 2976. Yeah, this is a bit wild there. 2976 2976 wiki. So I'm gonna go wiki, and then why do they call 2976? Is it called because of? Yeah. So this is the crash there. CCTV still the crash with this jet left wing separated. Okay. On November 4th, UPS McDonnell Douglas crash short left takeoff from runway at approximately at least 9 people, presumably including all 3 members. Accident being investigated by that. Aircraft involved was, and this one flown in 1981. So again, a lot of. But why is it called 2976? 2976. Like, what's the reasoning for that? Yeah. So why is it called 2976? That's a bit wild. It's actually pretty ridiculously wild. 2976. Like this is again. So Dick Cheney died yesterday, and then flight 96. 2976 crashes after reaching 175 feet. So maximum altitude 175 feet. Let's go to the wiki on it again. 2976 wiki. Yeah, this one here. And UPS 175. Okay, so it reaches 175. So it reaches maximum altitude 175 feet. So like, who are they just putting these numbers in just for giggles or? Okay. Anyways, and the highest recorded ground speed. Yeah, but anyways, it goes, and then so flight 175 was on 9/11, and then the attacks killed 2976 people and injured thousands more. Okay, that's pretty wild. That's actually pretty wild. But again, it's obviously, and it's also the same time that Dick Cheney dies. So that's, and Dick Cheney is a huge D, so that's pretty wild. But still, yeah, that is just pretty wild. It can be just big numbered mining. Anyways, so that's that. What else we got in this show here? Okay, so that's pretty wild. Yeah, I'll say. Yeah. Why 2976? That is wild. The timing too. Yeah, I'll send this one here. Okay, so there's Foundering. Okay, anyways, I think Foundering. I think he liked some of my stuff before. Or anyways. Okay, so we're just gonna close some stuff. Okay, so this is this guy's message, and then see what else we had. Okay, magnets and repulsion. Okay, this is another thing that I'm gonna go over before we go to the gravity, the radio waves. I'll do that big time. Anyways, yeah. So Tammy says we'll do that. Yeah. So yeah, send me the screenshots and so on. All right. Anyways, hope you guys like that live stream on Saturday. Absolutely wild. But anyways, it was something else. But yes. Anyways, I have so behind me, I'll put that on the ground. So for those who are just showing up, I have here. I'll make this bigger. I'll make this huge. Okay, so I have it in the bottom. So I have this pet fence, and I have this Tesla coil. I'll start running it soon. I'm just charging the thingy here. I'm charging this thingy. This thing is just charging. Maybe a bit longer, and then maybe at the halfway mark I'll get it going. Ball don't lie. Touch on symbols of chaining and such last sense. Great stuff always. Plays into two towers topics. Yeah, definitely. It is pretty wild. But again, here at MES, it's like you can get lost in the numbers, and we don't get lost. We wanna get testicle for energy tech, anti-gravity, magic stuff. What on Saturday? Yeah, that was quite something else. But again, here at MES, the peeps were astonished at my keeping my cool mama jumbo. Yeah, it's quite something. But anyways, peeps, a lot of people are different, they have different personalities. Anyways, so I have that pet fence thingy. Oh, how do I lower this? My giant face. Oh, this is covering the whole thing. Okay, I'll lower this like this. I'll make this bigger. Yeah, anyways, yeah. Yeah, anyways, I'll just keep that set up there. But yeah, so what I will do is so because Nancy doesn't want any Hudson effect like the old Hudson effect self-replicated again. So what I'll try to do is the one I've always wanted to do was actually separate. No, deciphering from more numbers. No, I agree with that. But the thing is, what I'm trying to say is like you got to use that deciphering to create some anti-gravity tech. So the name of the game is anti-gravity tech. Everything else is just mumbo jumbo. That's kind of what I mean. But yeah. Anyways, and also, what's the channel guy's name? Ball Don't Lie. Ball Don't Lie. Let's go Dick Cheney. Conspiracy. What is this channel name? But is he like, how do we find these people that you're saying Ball Don't Lie? Like, I don't understand where you guys getting these people's names from. Are they just on X on YouTube? What are they on? Like, what is his name? Like, how do you just say a person's name and then how do you like what are you what is it, what are we even looking for? Videos. Well, basically, I was gonna do a check on if he talks about 9/11, truth, like real stuff. Okay, so it's like, what am I? Anyways, send me a link on these people. Okay, good evening, fellow and others. Good evening, 9/11 version. So yeah, so it's a bit later for you now, and yeah, so I'm just going over some stuff I also mentioned. So I have a testicle behind me. We'll get it running. And I have this one. I'll get it running up. Actually, at exactly 10:30, I'll get it running up. So I'll just show you what I have. So I got this pet fence. I got it set up. Let's go fence. And I'm just gonna do a test to see how because what I realized is you can actually hear. Oh, this is eye to eye. Okay, this is eye to eye. Well, like, what is that? Is he a channel? Like, are you guys like trying to do this? You have to make it easy for me. Like, how I can't. Is it a YouTube? Okay, there it is. Yeah. Okay, I'm gonna go over this guy. Ball Don't Lie. Okay, so this guy's Ball Don't Lie. Okay, so his name is Ball Don't Lie actual, but how you can't even search. Well, okay, let's go to 9/11. So there's two things I like is prediction because 9/11. It's like you gotta get y'all like people have to get it winnable. Is that a betting site or something? What is winnable? Okay, World of Sports, etc. Oh, so he's one of the betting guys. But again, what I do want to see is like, so there's two things with numerology mumbo jumbo. It's like, can you predict the future, and can you make it easy for others to see that you can predict the future? Because like it's similar to my Trump fake assassination videos. Like I'm telling y'all it's gonna happen, and then the fake assassination happens. Like that's kind of what I mean. But now if you're doing sports betting, like put the numbers out, and then shows how the money put some hard money on it. He specializes in betting. I know I understand, but it's like yeah. So the question is like get a track record of how your stuff is. and so on. And what I'm starting to do is now actually I'm trying to. So I paid for Grok for 1 month, the Krog Super Grok. So I have Super Grok now. Because I'm trying to get this crypto trading one. I'm trying to make it like next level. Okay, so basically I started with $100. Now it's well, it's 120 right now. So and I'm telling you, okay, so it told me to buy BTC yesterday. So I'm gonna be using this like daily or every other day, and see how it goes. And then if it starts doing well, if it goes over 200, I'll start putting in my live streams and so on. You can see patterns of actor guessing. No, I agree. I'm just saying show me his track record, and then also what is his biggest predictions coming up. So like I was trying to say, it's like similar to like my stuff. So if people say, hey, this guy talks about 9/11, yeah, but what does he actually? What do I actually say about 9/11? I know towers turned out. That's not a. You don't need to like watch my videos to know exactly what I mean. Anyways, that's part and parcel of stuff. Anyways, let's go back into this thing. So I have this pet fence. It's going to stay focused. Yeah. So anyway, so I got this word here. I'm gonna test out because I can hear when you have the Tesla on. If you have headphones on, for some reason I could hear it. So I could hear like this buzzing. But then this one when you spark with the spark gap, it literally almost burst my eardrum. So and during the spark gaps is when a lot of the Hutchinson effect stuff happens. Is when the spark gap discharge. So I'm thinking. Okay, so I have a detector. I can literally detect testicle like strength, and then I'm gonna put this cage in there. Okay, and I'm gonna check how strong it is with this on now. So and then I have the other fence. I have the wire mesh thingy. So anyways, this is the thingy I got. So it's like for pets or whatever, but it's pretty good. And then I have that set up. I might buy more, and I also have this chicken wire to see how much if this is needed. First, I'm going to test out if I can hear it. I'm going to try to do a spark gap discharge while wearing this on, while the pet fence is on. Because the thing is, the reason I need this, because I don't want my computer damaged, because if my eardrum's almost destroyed. Imagine what it's doing to my phone, my computer, and so on. And if I can like literally cancel out everything outside of this thing, so that means I can literally create a perfectly safe environment for Hutchinson effect mini experiments in here, without any damage. But also, again, this raises the question, if it's affecting my headphones, I actually think radio waves are, like, they are gravitational / inertial. Like, it's actually vibrating. It's not just some sort of electrical, magnetic mumbo-jumbo. I think it's actually some physical movement of, like, and this is where the I know Dino calls it gravitational, gravity. So radio waves are electrogravitational, not magnetic. Anyways, we'll discuss that in a bit. Anyway, so I have that. I'll get that running up in 3 minutes, and so on. And what else do we have here? So we went over this guy's comments right here. Also, this guy. Okay, this guy was gonna show up to. James was actually gonna show up to my. He was actually gonna visit Nancy as well. John and Nancy wanted to come visit, and he appears that I'll not be able to swing a trip like this within a couple weeks due to some obligations that showed up. If there's a later date, possibly, then if conditions improve. Honestly, I was hoping you would say it would be next year. Stoked that it was so close to where I visit family. I'm a drone pilot, so my work isn't always work. I can go anywhere. So next time you go to Cali, you can just plan a family visit. But yeah, no worries. We'll let you know next time I fly out to Cali. Yes, and so physical. Wireless radio sets with crystal can be powered and produce sounds by radio waves alone. Wireless radio sets with crystal can be powered and produce sounds by radio waves alone. So wireless radio sets with crystal can be powered and produce sounds. So you can power by sounds? No, so you can power it by radio waves, and they can produce sounds? Can you please, like, tone it down, or like simplified for the normal folk here. It is a Thanksgiving timed event. The physical movement that is so fast that we cannot see it. Yeah, I know. Again, it's ether movement. Everything's ether movement. What I'm trying to say, like, the reason I'm saying like a gravitational inertial, I'm saying it's like an actual thingy that you can move actual objects. But the thing is, why is it only like here? And the question is, yeah, the question, what material is it that causing this to vibrate? It's like the it's like clean this up a bit. Okay, it's been a while since clean. Anyways, I need to clean that up. Anyways, so I'll do that in 1 minute. I'll just have it plugged in and see what happens. And then the other, I have some other question, guys. So that was this guy's questions. And then I have another one here. Its original radio was over crystals, and there's old military videos on YouTube displaying this. So yeah. So that's a cool. We'll go over that. So John sent this one here: gravity wave detector, gravimeter.
To it, so
Okay, so he has a gravity wave detector. Okay, so let's see what he says here.
what if I move that a little bit?
Okay, oh, this is the oh, he actually has
It's swinging.
he actually has a Cavendish experiment.
Yeah. Adjustment works just fine. Let's go back.
Yeah, but you have to be
okay,
but
you
it's
know
not gonna move that fast because it's something not gonna move that fast because that's this is probably like a wind current or something.
I know you like balls, but let's move it this way a little bit.
So let's see
I'd like to use a better sensitivity.
okay, so this is
They
he
always
has
say
that.
use fishing line or some strong material. I'm using a spring actually, a very fine spring.
Okay.
Stretched it to its limit.
Oh, that's
But
cool.
Olivia, oh no, love. Come on, be good.
That's Mr. EVO.
A laser and a mirror mounted on the center part.
Okay, now it's pretty cool. So I'll just summarize this and then see what AI says just for us. Okay, and now we'll do the test now. Okay, summarize and also post this right here. Okay, that was this Telegram. Okay, that should be here. Yeah, this should be here. This should be like this. And go to the bottom. Okay, and then this is here. Okay, so we'll keep that and then put this in a separate. So this is for my searching. This is for my just posting stuff I find. Anyways, so that and then we'll go over. Chris Berger had some comments about Atwood machine and so on. So we'll go over that. But I'm gonna set this up now. I'll make this big. Okay, I'll make this big like this. Okay, so that's pretty good enough. Okay, I'll make it like that, and then I'll make it here, and then let me know how it looks like. So there's my pet fence thingy, and use the only power of received radio signal to produce sound, needing no external power. Okay, interesting. Yeah, so I'll look at some of that. Yes, original radios were crystals, and there's old military. Okay, yeah, so definitely. Okay, we will play some of that. Okay, so anyways, I'll just show you what I'm doing. I'm gonna do a quick check here. Actually, yeah, let's keep this here. All right. Okay, so I have this thingy. Whoop, where's the okay, so I have this and so on. Okay, this is gonna be the power supply or the controlling it. Okay, but before I even go further, I need to before I test it out, I need to go review what in the world, how does it work again? It's been a while. Okay, so we'll do that again soon. I'm gonna scroll this back. Okay, let's go to here and write Tesla coil. I forgot the instructions there. I gotta go Tesla coil. Give a quick tutorial and instructions. Yeah, quick video tutorial and manual on the Tesla coil. Let's play this right here. Okay, place a discharge needle above the equalizing ring and extend the needle tip out of the equalizing. Oh, I never did this before. Okay, so that's the discharging one. Okay, I never did that before. Okay, so I'm gonna do this. Okay, so we got this little needle. Oh, this thing is not even set up there. Okay, so we got this right here. Okay, so we got this needle. Okay, so yeah, so I never did this before. So this is a discharging setup. Let's see what happens here. I'm gonna put this on top like that. Okay, so that's discharging needle. Okay. And then extend the needle tip out of the equalizing ring. 2 to 3 centimeters. Yeah, that's good enough. Insert the fiber optic into the product base. That's, yeah, fiber optics in there. That's pretty interesting. Pay attention to the card slot. Okay, then you gotta slide it in. Put it in, and then you gotta slide those around. So I did that. This is super annoying.
Yeah.
Connect the fiber optic cable to the controller and keep a distance of more than 1 meter from the equipment. Okay, I never actually, it's probably, because I gotta go 1 meter away. So I can keep that right here, actually. Okay, so we have this right here. So I'm pretty much 1 meter away. Okay, that's pretty good. More than 1 meter away, so it doesn't get affected. Okay, so plug that in. I have it plugged in. Okay, so I have them both plugged in. Okay, so that's good to go. And I just gotta power up the thingy. Okay, that's this short game.
这种状态是最低的。
Before the equipment is connected to the power supply, turn on the controller, check whether the frequency and pulse width is at the lowest state. Okay, so we gotta go to lowest state first, so it doesn't blow up. Okay, let's see what happens here.
然后这种状态，这种
I also have this at 220 volts. Okay, it's gonna be super, super, super strong. Okay, Gonzo says we can hear you. Okay, Gonzo, Johnny's on the show. Let's go. Alright, Gonzo, epic stuff. Okay, we got their only Rumble guy. He's taking over prime real estate on Rumble. Okay, let's see what it says here. The brighter the lamp, the higher the status. Okay, let's go back here. This is good thing. I'm before the equipment is connected to the power supply, turn on the controller. Check whether the frequency can. How do I turn it on? So this is where's the on button? Okay, this is turn both on like this. Oh, turn both on. Okay, so both are on. Okay, and this is a lowest rate, and then and pulse width is a lowest rating. So I have them both low.
然后这种状
The
态，
brighter the lamp, the higher the status. So I have this like this. Okay, so now it's gonna go right here. Okay, so that's the highest one. Okay, there's the okay, make it lowest. A brighter the lamp, the higher the status.
这种状态嘛，灯越亮，它表示状态越高。
Adjust it to the lowest state. Okay, so, but what is each one? Brighter the lamp. What's the first one? The frequency and pulse width. Okay, so the frequency is yeah, so how fast it is, and then pulse width is yeah, this is interesting. What in the world is pulse width? What is frequency and pulse width? What in the world are these? I'm gonna go ask Grok. What is frequency and pulse width controllers? Yeah, on a Tesla coil controller. And before we go further, I'm gonna set up a new thingy. I'm just gonna call this new project. I'm gonna call this Hutchison. MES Hutchison effect, because this is gonna be MES is Hutchison effect replication. Okay, what is frequency? No, I'll just do this. Okay. So now everything will be inside this. I'll do that later. You could attach the documents and everything, so you could actually create a full one. And so maybe I can attach some stuff here. See what I can attach. Upload a file. And see what I can upload. I think I had some in here. Japan. Go to the Hutchison effect. I think I had a bunch of the papers he had. Oh, free energy crystal equipment books. Is that the books? Paula Violette. We can add. Yeah, so that's the cool thing. We can add everything in there. I just want to add the Hutchison effect. That he had a giant paper. Interviews and shows. I'll just go to, was it meta? No. Let's go random. Was it random? I'll see the type. Just want to get I thought he had some books. PDF document, hard drive. No, that's that website. Let's see, AI. No, Mr. EVO, random, no. I'll click this. Meta. Is there something in here? And American Anti-Gravity, Hutchison, hard drive, George Hathaway. Maybe it's in this George Hathaway. Okay, yeah, the Hutchison effect PDF. I'll just put this one in right here. This is the Hutchison effect, and it's Hutchinson. So who's spelling this wrong every time? Anyways, yeah, I'll just add that. Now we'll do a new thingy here. Pulse width on a controller, Tesla coil controller. Okay, what is that? So everything I do that's related to this will be in this project for the AI one. And yeah, see what happens. So what is that? Oh, I have a Grok 4. I'll just do Grok 4 fast. Okay, quick answers. Give me some quick. I don't want full research right now. Grok 4 fast. The rate, the frequency refers to the rate at which electrical oscillations occur, measured in hertz, indicating how many cycles per second the coil produces. Pulse width is the duration of each individual pulse or discharge within those cycles, typically in seconds, affecting the energy delivery. The document mentions specific frequencies like 200 pulse durations of, but so it would go on, and then there would be a break from a Van de Graaff machine, illustrating the role in the Hutchison effect. Wait, can you explain, wait, why is it, no, yeah, this is, simplify what you mean by the, frequency again. Pulse width. Is the, frequency released, and then there is a pause, and the frequency is done again. Okay, let's go grok for think of Tesco like a musical instrument that sings with high-pitched electrical pulses, sparks, and darts. Controller manages how it sings, specifically the frequency and pulse width control the rhythm and timing. Frequency, this is the speed of the buzzing, goes buzzes. It's how many pulse wiggle cycles or electricity happen per second. And then he used 200 and 400 kilohertz for main oscillations, making the coil resonate sharply. Pulse width is the length of each note before it stops. Oh, that's the pulse width of this. So it's gonna go and then we'll stop. Like how long do you hold the key on? It's the on, not the off time. So pulse width. It controls how much energy gets dumped into it. Okay, so anyway, so I have these all at the lowest state. I'm gonna go and let's go back here. So anyways, I understand now. This is kind of what I mean by every sentence needs to be like explained. This is how I kind of do my everything. So sometimes it takes a long time for me to do something, but that's because every sentence I need to like double check every word needs to make sure so it makes sense. Anyways, so we have okay, this is which one is which? Okay, so this is the let's go back. This is at 29 seconds. Okay, this frequency pulse width knob. Okay, so this far one is the knob of how that is how long it's going to be on for before there's a delay. This is how much the frequency is. Frequency knob, main switch, music mode. Oh, that's connecting the mode switch is turned down to normal mode, up to music mode, and the two knobs are turned clockwise to increase arc lengthening. Okay, so that's yeah, you can arc lengthen mumbo jumbo. Okay, so let's just go back to 29.
这种状态是最低的。
Okay, before the equipment is connected to the power supply, turn on. Okay, this is before it. Yeah, there's no power supply. It's off right now.
这种状态，
So I
这
am.
种状态嘛，等于量，它表示状态越高。如果是亮度高的话，就要调低了，然后关掉。
Device connected to 220 volt power supply. Yeah, so I had to get a order a second cable because my cable, the one that he sent me, doesn't have was for the wrong socket. Like it's for like European or something. Anyways, so I had to order a 220 volt one because the only one I had was 110 volts. Okay, these are the ones I don't have this one. This is like some old school. I don't have these angled one. Device connected to a 220 power supply.
打开电源，打开
Keep distance more than 1 meter and then turn on the controller switch.
我出来，把这电掉。
Yeah, slowly adjust the controller knob. Oh, and this is that's I have that spark discharging a needle there. Okay. When switching to the music mode, first keep the player's square wave music in the playing safe. This testicle in the playing state. Then link one of the audio to the other phone.
别上，再接到这儿。
How does it do that? Wait. Oh, okay. So when switching, first keep the player's square wave music in the playing. So you play this music, and then you plug it in.
别上，再接。
And the other end is connected. Then you connect it on after. Then turn on the switch, controller switch. Okay, so we will try to do that actually, maybe. Okay, so I never had the discharging thingy before. Okay, so now we are gaining some info. Okay, place a top pin on the pressure equalizing ring at the top. This is what I never did, so I don't know why I ignored this. But okay, cycle. Turn the arc extinguishing knob, and I think that's probably why my eardrum blew up. Because like I never had a discharge, and then when I would touch it, it would be like a massive burst. Turn the arc extinguishing knob counterclockwise to adjust the light brightness to the lowest, and then turn off the arc extinguishing knob. Basically make it lowest. Connect the two ends of the fiber optic. Pay attention to the protrusions on the fiber optic cable and do not forcefully push it. Rotate it first, then plug it in. Connect the 220 volt the host first, and then connect it to the 220 socket finally. Oh, it's supposed to the device and then socket. Okay, that's good. Good to know. Finally, turn on the controller and turn on the potentiometer to start. Okay, turn it on after. I need to turn these off. Okay, connect power and then turn on controller. Attention, top pin must be installed and powered on. It is recommended to use within 3 to 5 minutes. If playing music, it should be done within 2 to 3 minutes. Turn on the main switch downwards. Mode switch turn to normal mode up to music mode, and the knobs are counterclockwise. Okay, we'll try some music actually as well. If we'll try that as well, and then see what happens. Okay, and then this is the turn main switch downwards to turn on, the mode switch turn on to normal mode. Anyways, I don't have time to read all that. Okay, so all right, we're going wild, guys. We're gonna do some experimentos. Okay, whoops. Whoops. Why does it do that all the time? Okay, so we're gonna go like this. Okay, so we're going live, guys. Okay, so we're gonna go do some mumbo jumbos. And also, there's Attila. So the question is, where's Attila? Are you going to do something with it in a live stream someday? Yeah, I'm doing that right now. Okay, okay, this is Attila. 1 second. You guys aren't seeing it, so I will share this. Whoops. Why does it not show this? Okay, it's like this, just everything's trash. Okay, this. So yeah, there's Attila messaged earlier, and I haven't seen him in a while. So where is he? Tesla coil live right now. Okay, so we're going live. We're gonna send this to him, and basically and then also how are things in Iran? So I haven't heard from you in a while. I haven't heard from him in a while. Okay, so anyways, so that is him. Okay, so we're live there, and this thingy is all the way down to the bottom. All right, so we are back in now. Anyways, Elijah Jack, I missed the one with John. Is John joining today? A true testicle diameter should also be its height. Scalar wave square the circle. Yeah, interesting. Yeah, I know John's not in this one, but he typically he says he watches my streams at night when he's not in. But yeah, so Saturday one's pretty wild. So brace yourself for that. Just as a mini heads up. Anyways, so I have this big thingy here. I have to cool in the ground. Right now I'm just gonna test out how well my thingy is there, but I don't have a discharge thingy, so I think that might not even need it. I'm gonna do some testing, and I'm gonna keep this headphone on. Okay, I'm gonna keep it on. Then I'll unplug it as well and see what happens. All right. Actually, I need to keep this on at all times. Okay, I'm gonna keep this on. I'm gonna unplug this. Okay, so I'm gonna keep this headphone on at all times because it literally, you can hear the testicle. And now I have the discharge thingy on now. So I'm gonna plug this in, make this bigger. Where's the thingy there? Okay, I'll make it further back. I have a coin there for some reason. Okay, let's see what happens here. It might have a bomb. All right. See what happens here. Oh my knees. Okay, I think those are all off. Okay, so there's the discharge. What is this? Okay, so we have this. Okay, and now we'll see it without anything. This is which one is which? Testicle. Okay, so this is frequency. The pulse width is on the left. Okay, so this can be a left one. Pulse width frequency. Okay, it's not doing anything. Okay, so nothing's happening. I'll take off this discharge thingy. What does it do? Even do? Okay, so now the discharge is off. This I just want to hear it, and then we could plug this thingy around it, put that around it. Nothing's making any noise. Might need a while to load up. Okay, so school's not doing anything. Okay. Do I need to just wait? I think last time I just had to wait. Okay, this thingy. Okay, so have that cage there. See what happens now. Nothing's happening still. I'm gonna lower my desk so you guys can see. Alright, what in the world's happening? Why does it stop every my so my computer, this thingy, the tables go down smoothly because it's all plugged the same socket. I need to plug a different one for it to go down properly without stopping. But anyways, so what in the world's going on here? So it's not doing anything. Okay, so anyways, we have no idea what's going on. Okay. There's no buzzing or anything, guys. Okay, I'm gonna see what. Okay, so that's 110 volts. Turn these all off. Let's see what happens if I go 110. It's not doing any noise. Alright, so I have no idea what's going on now. I think we'll try something else. Okay, bear with me. It's, let's just try it again. What is this going in? Let's see this stop. Come on. See that coming off. This might be it then. It just won't come off. Unbelievable. I need to wear some gloves. 1 second. We need to figure this out. All right. This is just brutal. Yeah, so I need to figure this out. I'll try this one more last try, and then I don't know why it's not it doesn't seem to be working or building up charge or anything. Just this thing is stuck now. Yeah, so now this thing is straight up stuck. Alright, so we need to figure this out. What in the world is going on here? So I think this is probably why then. It's just stuck. Come on, let me break it off. Okay, it's off. Unbelievable. Try this out. Let's switch over this. I'll use this as a spring powered one. Oh, that goes in there. Okay, I think I did it wrong. This goes like this. Okay. Okay, so this goes like that. Alrighty. Okay, that's a discharge everything. That should be working. Like, what is happening here? Okay, so nothing's happening. Like, the red thingy, this thing is turning red. Oh, there's no. Alright, we're back on. Oh, yeah, I blew up my ear. Alright. Okay. So I don't have the discharge thingy on it. The good thing I was wearing this, it won't shock my hand. Like, what is this? It's like, there's no indicating, no noise. Okay, discharge this all. Ah! What is this? Alright, this is. Okay, let's see if I could do it through this thingy. Okay. Alright, this thing is scary AF. Okay, so see if we can discharge everything. Okay, that did discharge. Ah, why is it so strong? Okay, so I need to turn these off. Okay, so I need to hold something even stronger. Alright. Okay, so it is working. And I am scared AF of it. I'll put this in here. Okay, so it needs to be on it, the discharging at all times. You can't have it spilled up, otherwise it's gonna destroy the world. Okay. Okay, why can't I just pick this up? My goodness. Let's see if I could, is there any way I could just drop it on? I'm gonna just drop it. I can even, like, put it on there. Let's put this on. Okay. Stop. Okay, it's done. Okay, so I need to put it like that. Alright, so we're good to go. There's the noise, finally. So that's what this discharge. Y'all can hear that? So that's the discharging thingy. Okay. And now, see what happens if I take this off. So I have the noise. So I'll just so it is vibrating the air. What did it sound? MES turn up in a new dimension. Okay, yeah. So, anyways, I'm trying to learn what in the world's going on here. Okay. So it shouldn't put on for too long. Okay. Okay, so I have these off. It's discharging, and okay, so I almost like blew up my eardrums. Okay, so now we are Okay, so I understand what the world's going on. I can't believe I didn't read this before. Like I never saw the beginning part. So you need to actually put that on top. So again, this is why I need to like pause, as Nancy would say. Anyways, okay, so I want to play the music, and then we'll get into radio waves and see what in the world they are. Okay, so. All right. So, anyways, spark gap discharge. I could, yeah. Before when I don't have that plugged in, I can hear it through this thing. So basically, it's discharging in here. Okay. So what I'm gonna do is I'm gonna put some music on. I need to get a. Oh, I have the headphones. So we're gonna do some music, and we're gonna play some music. We're gonna play some me talking. Yeah. Actually, let's go right here. Oh, I just. My goodness, this doesn't have the. I need to switch them over. Okay, I need to. My headphone. My phone doesn't have that one. I'll use this thingy. Okay. Okay. Miguel 1990 says even I'm scared. Yeah, I'm scared to get in. So the thing is, I learned by doing, but this isn't something you should learn by doing. You gotta like actually research, so you don't like blow up or anything. Anyways, okay, so that should be off then. Okay. Oh, my thumb almost like blew up my thumb. Oh, that still hurt. Okay. So now this goes to here. See, does it? It should be done. Okay, so it is discharging. No, that it doesn't go in there. My bad. It goes here. It goes into here. So we're gonna play some music and see what happens. All right. We're gonna play. Let's see what happens on the YouTube. Oh, I'll just put on Telegram maybe. This is exit this thingy. What's the Okay, I'll play this maybe. Oh, okay, I'll play the one where I was physical altercation with the this is the one I had the physical altercation with the neighbor when I was trying to steal his house. Anyways, we'll just play it, see what happens. All right. Anyways, so we're going live. Okay, I'm gonna put these other headphones on so I can hear extra stuff. So I don't even think we need this one. Okay, I'm gonna plug this in. 1 second. All right, so we have the spark gap discharge. We'll play some music and see what happens. I'll put these on just so in case I can hear extra stuff. So anyways, so this is extremely dangerous. So the spark gap, you need that, otherwise you're gonna blow up everything. Okay, so we're gonna play some music. So the thing is on. We're gonna play this on here, music mode. Why is no music mode? No, I think I know what it is. That's music mode. What do these buttons do? Main switch, music, normal mode. Okay. So I think they said you gotta plug it in. Okay, so I have that sound on. I think. Nothing happens. Okay. This audio one doesn't work. Let's try that again. Okay, so anyway, we'll figure that out next time. I'm gonna turn these off. It's discharging. And actually, no, I still need to do one more test. Okay. We'll do the try to play music another time, but I'm gonna do a test, and this is the dangerous one. That's without the spark gap discharge. So you gotta release the spark gap discharge, and then see if I can hear it with this coil on. Okay, I'm gonna remove that off. Okay, now we're doing this the dangerous one. This one, I didn't realize how dangerous it is. Yeah. It's pretty ridiculous. So I'll keep these headphones on. I will remove this. And I will just, I'll have to unplug this on. Plug this, okay. Okay, alright, so anyways. I'll remove this. Okay. And now, I'll just plug this in. And now it has no spark discharge, so all it is going to be building up infinite charge, and it's extremely dangerous, but I just want to be able to hear it if I can or not. Okay, so now it's building up stuff. Yeah, I can hear noise. This is pretty dangerous. Oh, it's discharging through this thing. I can hear it, okay. So now yeah, I can hear it. Okay, there it is, there it is. So I can hear it with this. So what's actually happening is it's discharging into this. But if I put this on over it, I can physically hear. Okay, so it's stopping there. Now I can't hear it. I can hear it when I go that close. Okay, so it does work. Okay, now that's smaller ones. So it's vibrating that more. Oh, I can hear some smell. Okay. Okay, so that is extremely, extremely. It's like burning some stuff. Now I gotta discharge it. And I'm gonna discharge it by throwing this on there and running away. Nope. There it is. Okay, now I can grab it. No need to worry about it there. The charge is gone. There it is. Okay. We're done. Alright, so we got that set up. Let's unplug this stuff here. Charge this. Okay, so I did that wrong before. This goes in. Alrighty. Okay. Alright, we are back. We're back in the show. Okay, so we almost blew up everything. Oh, my thumb still hurts. Alright, so I learned the hard way that testicles build up charge and then charge becomes extremely dangerous. Alright, we are good to go now. We're gonna put this around. I'll fix up the mic setup there. Alright. And yeah, this is again for those peeps when they're talking about numerology mumbo jumbo. Yeah, there's Illuminati mumbo jumbo, then there's also build something that's scary AF mumbo jumbo. Alright, so we almost blew up everything. Anyways, I just want to listen to how do they do the how does it actually play here? I mean, how to get the music part. First keep the player's score with music in the playing state. And then you just plug it in. That's what I did.
好，接上。
But I needed the adapter. Maybe if I use my other phone. Okay, I'll try this next. I have my old phone that has the old, because I needed I had to use the adapter for my new phone. This adapter. So it might be that might be a reason. So I needed to use that. Anyways, that'll be for another day when I regain my confidence back. I am scared AF. Alright, Alright, so anyways, so learned one thing, and so that'll be another stream of what is a charge? What in the world is electric charge? Okay, pulse width, okay, alright, I'll say got it, thanks. Got it. Whoops. Now this doesn't even work. Unbelievable. Like, what planet am I on? Now the keyboard doesn't work, so I gotta unplug the keyboard and plug it back in. I think I probably dislodged some of the wires. Okay, which one is which? Okay. So which one is which? I gotta find which one is which. The keyboard's not working. Okay, keyboard's working now. I have to unplug, plug it back in, and keyboard is back up. Alright, alright, say got it. Thanks. Alright, so anyways, so now we have this attached there. Hutchinson. Okay, I'm gonna go and correct that ASAP. I cannot believe it's using that name. I don't know why, who used that Hutch infect. Gotta see what it is. Attach files, Hutchison, kind. Okay, so what I'll do is I want to get all the PDF, all the documents. Where does that go? Equipment, Hutchison, 911, MES, HE replication. Okay, so we have our own setup there. Testicle. Oh, there's the manual. Okay, so there's the Excel. This is the meta. I think I had this George Hathaway. Okay, Hutchison. Like, what? Who in the world is writing this? Mind bending. And then let's see what it says inside here. Yeah, the Hutchison files. Okay, this is 276 pages. Okay, so the whole mind bending book's in here. Okay, this is pretty good. I'll go like this. Okay, this is pretty epic. Okay, so there is. Yeah, this is pretty good. Does he have any designs stuff there? Okay, there's this. This is some cool stuff here. And this is some high quality photographs too from way back. 19 something. 95? When is this out? 90. There's John. There's John with the hair. Here's some high quality photographs, guys. So I don't know how I got this PDF somehow. And there's John's setup there. All right. Oh, Alex Pizzaro and a bunch of sources. This is no, this is absolutely amazing. Let's go. I think I'm gonna go search jerk or jolt. Yeah, called jolt. Okay, so this is where he did the experiment of hyper acceleration. This is from Thomas Vallone was saying that some of the levitation stuff that John was doing, they would accelerate. They accelerated linearly. So in other words, the acceleration rate was increasing in a linear fashion. In other words, that's some next level setup there. That's like it's basically constant jerk or jolt. The acceleration of acceleration, constant. So that was a unique thing. It's kind of like, think about if you had a constant a constant acceleration is like gravity, like but now if you have a constant increase of acceleration, which is like gravity for acceleration. Okay, so gravity for gravity. Okay, I'm gonna go cancel this one. Attach, upload a new file. So this is the now I just did that correct the spelling. So I'm gonna keep this all MES Hudson effect and so on. So it's gonna be absolutely fascinating to see what we come across. And yeah, anyways, I'll try to play the music one on a later date, and let's see what else is happening here. I'll keep that open. Actually, I'll play this. Yeah. Anyways, we'll go now. We'll listen to what is actually gravity waves and so on. And yeah. Okay, this is John sending me some stuff here. I just saw a modern way to extract energy from water while watching this idea of gravity mirrors. No, that was Charles. Dr. Meads here, also others. Okay, I'll close this setup here. What in the world's going on here? Okay, and I want to see what the summary says here when I summarize John's setup here. Did it refresh? Refresh for summary. Okay, no summary was produced. Anyways, okay, so I had I'll review the other question later. I'm gonna go to gravity waves. I mean radio waves right away. So radio waves. So we're gonna go radio waves. What are in the world are radio waves? Okay, isn't it safer to use rubber gloves? Okay, we'll do next time. Mega. Okay, so smart thinking there. I was just using some gloves. The reason I wore these gloves was just to tear off thing. I plugged in the wire wrong. The cable for the controller to the Tesla coil, so it was stuck. I jammed it in, and I needed to pull something that doesn't hurt my hand. So yeah, so I'll wear rubber gloves for dealing with the other stuff. That was pretty interesting. So radio waves, let's go right here. Radio waves, formerly called Hertzian waves, interesting, are a type of electromagnetic radiation with the lowest frequencies and the longest wavelengths in the electromagnetic spectrum, typically from 300 gigahertz. So basically, it's a type of electromagnetic wave between 300 gigahertz and yeah, 300 gigahertz and wavelengths greater than 1 millimeter. So basically these are how tiny is this? Yeah, basically 300, yeah, that is a tiny. So 300 gigahertz with wavelengths that are greater than 1 millimeter, about the diameter of a grain of rice. Oh no! Oh yes. Yeah, so typically, radio waves have a millimeter, just slightly bigger than a millimeter in diameter of grain of rice. Yeah, so I'm gonna probably need a yeah, smaller setup there. I'm gonna go see what here. Do Tesla coils produce radio waves? So what do they produce? What is in the world's going on here? Let's go grok normal auto. Just choose auto. They function as high voltage, high frequency resonant transformers that generate electromagnetic oscillations in the radio frequency range, typically from tens of kilohertz to several megahertz, creating broad spectrum emissions that propagate as radio waves. These waves can travel through the air, interfere with nearby electronics and radios, TVs, wireless signals, and even enable wireless power transmission or early radio experiments, like as Nikola Tesla demonstrated Plus, cleanliness could help with conductivity. Interesting. How it happens is the secondary coil resonates at a specific frequency, producing rapid electrical discharges, arcs that emit radio frequency across a wide bandwidth, not just a single narrow. So it does a wide one. Interesting. Not real world effects. A running Tesla coil can jam local radio reception for hundreds of meters or more. Historical note, Tesla coils were key in early 20th century radio development, allowing tuned transmission and reception of signals over distances. In the context of the Hutchinson files PDF you shared, John Hutchinson's early apparatus explicitly incorporated Tesla coil operating at 200 to 400 kilohertz, a low to medium radio wave band, but would have radiated radio waves as part of the standing columnar waves and fuzzy discharges he described, likely contributing to bizarre interference effects observed in his experiments. If you're experimenting or simulating one, safety, of course, high voltages are no joke. Let me know for tips on tuning or shielding RF. Okay, so that's good stuff. Yeah, we'll do that next time. I'll ask Rock, give me some safety tips. Okay, so every time, I'll just say, anytime you mention frequency, give me the wavelength too, so that I can better visualize it. Yeah, so again, frequency, if the frequency depends on the wavelength, I want the wavelength. Like, I don't really care, because the frequency is it's how many times in a second. Like, that's not a thing. The wavelength's all that matters. In meters next time, or millimeters. So when someone says 200 kilohertz, so John was using 200 kilohertz, was basically 1.5 meters. Okay, so because again, a frequency of what? It's like, what do we because if it's all going the exact same speed, then all you're saying is that this is in one. So yeah, basically frequency. What they're saying is how many times in 1 second does the wavelength propagate. So for example, this is saying in 200 kilohertz is saying that in 1 second you have 1,000 times of 1 meter, 1.5 meters. So the total distance. So like, it doesn't make any sense. So in other words, what actually matters is 1.5. So this is the only thing I care about in my head. So when someone says 1 megahertz, all that's happening is you have a 30 centimeter laptop screen vibration of the of light, or the ether. Okay, so okay, rapid decay for CPS. Okay, this is a pulse rate. 4 CPS. This is how often the whole system thumps. 1 pulse for every 0.14 seconds. So 43 kilometers. No, no, I'm saying only frequency. Don't give me wavelength or pulse, just for RF. Yeah, not for pulse rate. Yeah, pulse rate, that's a cumulative thing. I just want to know what's the actual thing vibrating. Okay, yeah, good enough. No, just stop. We don't need anything. Okay, okay, so simple RF wave is 1.5 meters, and so on. Okay, so now the question is, I'm gonna go ask the one that I have quickly. So this is the one I have. This is seller, eBay one. Okay, then I'm gonna ask it. Yeah, I just prefer this one. Okay. Yeah, I prefer this. I don't want the giant freaking thing. I prefer this response. Okay. The size and visible ripples pouring out of the coil. Okay, so 0.75 millimeters. So basically, he's dealing with meter long oscillations. That's why he's able to like affect things big time. Okay, so and then when you have a whole bunch of them all over the place, you can like interfere them together. So I'm gonna go give me wavelength frequency of this, yeah, range of this coil. of this coil I got. Let's see what this says right here. And there's conversations. Okay. There's files. Okay, so secondary coils 5 to 7 millimeters. Okay, so we have really, really tiny. 20 to 30 centimeters tall. That's how tall it is. Point magnet wire. Okay, so with magnet wire measures your. Okay, use scope frequency to sweep 100 kilohertz, 300 megahertz. And then wavelength is 1 to 1.6. If you show your. Okay, this kit's range overlaps nicely with his early setup 400 kilohertz, 1.4. Safe building. Okay, so. Okay, and then what's the arc thingy in here? Top load 2.5 capacitance. 200 at 200 kilohertz operating frequency at 200 to 2 megahertz. That's what we have. So pretty much the same as John's there at 2 megahertz, but it can go all the way down. So it goes 200 kilohertz. You can go to 1.5, about the height of an adult. Waves roughly the size of the coil secondary. What does that mean? How would that be? Waves roughly. Then wavelength compact of your hand. Oh, but the coil's not that big. Okay, anyways. It's pretty wild. Okay, pre-wound and so on. Okay, so we got it. Basically, it's a 1 meter. And if you have that, yeah, so the cage basically stops it. So basically, that Faraday cage, I mean, that fence is probably good enough for it. Okay, so that's pretty cool. But I will get the other stuff. I'll edit as well. Okay, anyways, so I think I had a spectrum here. Let's see if I had a giant spectrum somewhere. I'm gonna go right here. I thought I did. Spectrum. Thought I posted this. Okay, I'm gonna go electromagnetic spectrum. Magnetic wavelength spectrum. So yeah, so wavelength is what I care about. Well, at least right now. Like electromagnetic spectrum. Yeah, so here's a wavelength, and again, when you get to see super tiny, that's why they do the hertz, etc. So radio is 10 to the 3, so about buildings to humans, and then I think microwave is a type of radio wave. I think I'm pretty sure. And butterfly. So basically, this is the kind of stuff that John was dealing with, but I think he had some radioactive substances as well, maybe. So maybe he had something, a few in there, but basically this is a spectrum. Okay, temperature of objects at which this radiation is most intense. These ones are extremely hot. This one's like cold temperatures. You can get these ones here. Okay, that's interesting. So these are extremely hot. So 1K about negative 272. Yeah, and then this is where you get cold melting and so on. Basically, when you bombard a substance with a bunch of these waves, you're gonna get really cold stuff happening. So this is where the temperature is. That's pretty interesting, actually. Yeah, all right. So we're dealing with this setup here, human size, so on. And I'm pretty sure microwave is a type of. Yeah. So here, right here, radio waves with frequencies above 1 kilohertz and wavelengths shorter than 30 are called microwaves. Okay. So we have microwaves are part of the radio spectrum. Yeah, so we have, and microwaves are just above 1 kilohertz wavelength. Basically, wavelengths shorter than 30 centimeters, or microwaves, that's in that spectrum there. So we get radio and microwaves pretty much part of it. Yeah, so that's pretty, it's some pretty interesting stuff. Okay, so I actually personally learned a lot. I don't know about y'all, but I pretty much learned. Yeah, and there's the temperature too. Okay, so we got cold melting right here. And yeah, okay, so I don't know why it doesn't. Let me just see if I can remove the white background. Like, why isn't it doing this? Just give me, okay, I'm gonna go copy. My understanding is radio wave reception does not reduce the transmission length. radio wave reception. Oh no, I'm talking about the Faraday cage. It will stop. It will, if you have like a small, if it's smaller than the wavelength, apparently you can like stop it or something. That's because I did a search up last time what's a Faraday cage. Okay, I'm gonna go to Google. Let's go to Google Images. Do a reverse image. I just want to get one with the just visual matches, just without the white background. And without the background set up like that. Okay, anyways, I'll just have to do it myself. I am going to do it myself. New project. Paste this in, and I'm going to remove project settings, white background. What is standing waves? Okay. Yeah, but I'm saying the Faraday cage I just showed. Literally, you can hear the noise on the cage. I don't know how much you can literally stop whatever. Radio waves. Go to meta. Spectrum. Okay, so now we have this. Delete, and I'm gonna open this up. Spectrum. Oh, I spelled it wrong. Spectrum. Okay, so the reason I'm doing that is just because this has transparent background. I don't want that. I want this right here. Okay, there's a white background, and we'll send this thingy. I'll close this. This is pretty interesting. Spectrum. Okay, and there it is, and I'll put it on this as well. Okay, and then we'll ask your question to Grok. Let's put this like this. Brave. Oh man, this is just trash. Why doesn't it have access to my own thing? Okay, so we'll upload that. Okay, so now we're just playing the way. Anyway, so this is temperatures of objects at which radiation is most intense. Yes, we got cold melting here. Steven says Faraday cages cannot stop standing waves. Scalar waves, I believe it, but scalar. But again, scalar is a Thomas Bearden type stuff. I'm somewhat from mainstream. Like it's a Tesla coil. I put a Faraday cage. It stops the signal. Like I don't know, does it or doesn't stop, or what does it actually do? I'm gonna go a new conversation. Okay, let's go right here. This person says this. Is this accurate? Okay, let's see. Okay, radio reception does not reduce the transmission strength. Faraday cage cannot stop. Breaking down claims. You're asking about two related statements in context. I'll evaluate for accuracy based on the established, tying it back to the setup there. Radio reception does not reduce, mostly true, but with important nuances. Radio waves reception does not reduce the transmission strength. This is accurate in the standard electromagnetic model. Receiving a radio wave doesn't meaningfully deplete the transmitter's power, weaken its output. Here's why. Okay, that's receiving doesn't lower it. The total power radiated is fixed by the transmitter, blah blah. And reception at one antenna doesn't dim the signal for others. Atmospheric fading or interference can weaken due to rain absorbing, but that's propagation loss, not from reception itself. Caveat why mostly in extremely specialized cases like a receiver perfectly matched to absorb all the wave's energy, impossible in practice for broadcast systems. There could be yeah, why can't I like just stop highlighting now? Okay. There could be a tiny back effect, but it's negligible. No reduction in the transmitter's output power occurs. This aligns with Hutchinson notes. The apparatus can run from household outlets without draining from any observed effects. Okay, fair. Yeah, it doesn't. Yeah, there's no pseudoscience here. Basically, it doesn't. Receiving doesn't weaken the source like a battery draining. Faraday cage cannot stop standing and scalar waves, I believe. Accuracy partially true for standing waves, context dependent, but false and pseudosonic for scalar wave, because scalar is a bit on the other side. It's gonna mix the kernel of legitimate science standing waves with the fringe territory scalar waves. But I could once I understand more scalar waves, I can ask it to stop putting disclaimers. Are excellent at blocking EMF waves, including radio frequencies like in those in Hutchinson effects. So Faraday cages are excellent at that. But standing waves cages can stop standing waves are just stationary interference patterns of regular EMF waves overlapping Hutchinson's standing columnar waves. If the cage blocks the traveling components, it blocks the standing pattern too. Grok is avoiding the implication for energy. No, we're again. You could tell it what to do. Like Grok is just a. It has the bias for mainstream, but you could remove that by telling it stuff. But I'm just trying to understand this part here. Faraday cages can stop standing waves, and then scalar wave is a separate topic there. Again, it considers pseudoscience, but that's for another one. We'll review it and so on. And the reason I just have it keep it like this is so I know what's the mainstream, what's the alt media, or just the alt stuff. Blocked with Faraday gauge. Yes, if traveling components are shielded. So again, yeah. So what you're discussing something else. I'm just saying the Tesla coil. If I put a Faraday cage, there is some interference. The question is what is interfering, what's not. Okay, anyways, so here's a spectrum. Okay. Oh, this thing is still not uploaded. Okay. I'll just close this. I don't know what's going on. Okay, if it doesn't upload, what I'll do is I'll post this right here. Okay, now this is frozen, so that's frozen. It doesn't even have that anymore. Okay. Yeah, I'll just put this like that. Or we need to upload it. This is just ridiculous. Okay, so we can upload images. So I'm gonna go with snippet. Snipboard. You have to manipulate Brock. It is a process. Yeah, I understand, but also we need to manipulate you guys. Like, just what is the actual basic point? Like, I have a Tesla coil and I put a Faraday cage around it. Like, God, there's no magic around it. And something happens. Okay, just copy. Like the amount of times I don't know why. Just mainly with this Max, just like copy once. I want it done. It doesn't. No, yeah, this thing doesn't load. Radio waves. Electromagnetic spectrum. All right, so anyways, so we're on the cold side. This is where we have the cold melting and so on. Okay, so it's on this spectrum. And I think the hot stuff is when you... Yeah, so I think the hot stuff is when you're literally... the waves itself is vibrating the individual molecules super aggressively. Whereas if you have a whole bunch of these radio waves, and again, it's in the cold spectrum, of these... interacting but like intersecting, so then you can make like let's say not a gamma ray, maybe let's say you can get to like this kind of wavelength here, but in the in the separation or in the difference between these two. What I'll do is I'll draw this out. So here's something that's pretty interesting. I just had a nugget of thought. Magnetic field is what makes a difference. Anyways, what difference are we? I read this thing word. What is a magnetic field? What does this thing even do? I'm gonna click like this. Okay, I'm gonna pop out my pen. So what I just had a thought is, so if this is on the cold spectrum, and let's say we had let's pull out the notes right here. So math Q&A. We'll go to okay. We'll go to general. No. We'll just go to new page. I'm gonna call this 43, and I'm gonna call this radio waves because I'm gonna try to draw this out. So now I can draw this out. So radio waves right here. So what I mean is, so if this is the cold, if this is the hot stuff, is when you have the super tiny waves like that. So let's say we have the hot is this. Let's say you had an atom. Oh, this is like jumping. No jumping. Okay, this is an atom. Or here is a piece of metal, and it has atoms inside here. Okay, etc. And if you're dealing with like a gamma rays and so on, you're dealing with literally tiny stuff here. And then this is high temperature. I'll say high Kelvin or temperature. High K. All right. So if you're dealing with if you're bombarding with a bunch of these, you're gonna boil it up and like melt it and vaporize it and so on. And yeah, so you get stuff like that. So that's high. I'll just put K for Kelvin or temperature. I'll just call it temperature. I'll erase this again. Let's make it easier. So this would be temperature. High degree. I'll just say degrees actually. High. Or I'll just put temperature. High T. Okay, I'm running with my left hand. Okay, high temperature. So this gets super hot, but and let's switch hands now. Magnetism is a wave intensity propensity. Okay, so now we're like 4 different words. I don't know. Actually 5. Yeah, 4. Magnetism, wave intensity propensity. So what is waving? Anyways, so here is, let's say we have this now. So we have these same atoms in here. I'm just going like super simplified. And now instead of using this, we're gonna use the cold temperature one. So we're gonna use this. We're gonna use this. Okay, so whoops, what is happening? Okay, I don't know what's happening. Okay, so instead, I don't know what is going on here. I'll just use my left hand. Probably touching something. Okay, so let's say instead of using that, we're gonna use the big one like this, which will avoid it. So now this won't do much to it. But then if you have a second one, bombarding it slightly off base. So now you have a slight difference. So see this difference right here? This is equivalent to this right here. But you don't have this extremely high like oscillation in there. But you can get some sort of micro effects with macro. So this could be, think of a micro. Now you have, and then you have a whole bunch of these other ones like this. So now you have like these literally gamma rays, or like probably not as small, but like you have some sort of high frequency type equivalent of this. So you have this one here, it was a high temperature. Now this is low temperature, because these are in the you're not vibrating everything super aggressively like this. You're actually just basically nudging these atomic parts. The small parts are being nudged because of these slight separation in all these. So I think we solved it. So hot it turns cold. Okay, anyways, guys. So we solved it, guys. I think this is MES solved it. Okay, we're done. Y'all, whoever, this might be groundbreaking stuff. I actually think it might be. Anyways, so we'll do experiments. But I think you guys, the 5 people in the stream, or plus Rumble, so 6 people, have literally, you guys witnessed some magic right here. So I think we just cracked it. Anyways, so again, that's kind of how I work. It's very like, if you can explain it to like a child, then you know you got something. Chart of electromagnetic radiations invisible. Holy, this is unbelievable. Alternating current, long wave radio broadcasting. Okay. Diffraction. Okay, so we have basically cracked the code on something, which again, we'll do some testing and so on, but I think there's something to it. All right, so that's that part. Okay, anyways, so radio waves are like this. So here's radio waves. Animation of a half-wave dipole antenna radiating radio waves showing electrical field lines. Okay, this is the part, like, what in the world is going on here? The transmitter applies an alternating current to the rods, which charges them alternatively positive, negative. Loops of electric field leave the antenna. And travel away at speed of light. These are the radio waves, and its animation action is shown slowed down tremendously. So this is, but what exactly is this? Okay, so we have that part, and I gotta go with the Einaldini one. I think he's onto something. Einaldini, man, like, what kind of names are these? Just call it something simple. So this one where I used that experiment of it. So he has this, and I'll see his papers right now. We'll pop it up. We have some time to go review them. Okay, so a radio antenna emitting electrogravitational waves. Radio waves are not electromagnetic waves. They are generated by electromagnetic means, basically oscillating back and forth. In reality, waves and light traveling in space are electrogravitational. That's why you get to affect actual like metal things. The calculated radiation pattern at a distance of 10 wavelengths is shown in yellow for various antenna. Blue dots equals electrogen accumulating at the end and producing an ether compression. So think of electrogen as basically some sort of particle that has that compresses ether. So the blue is compression, ether compression. Red is the ether rarefaction, basically the decompression. So that's like the void in the ether. And the compression is like condensed, and then the space between the ether compressions and rarefaction is a gravitational field. So here is this guy's setup here. So so if you have radio waves, I'm just gonna go back here. So he has. I want to get this model of this. Like, he wouldn't give me access to this thing. And apparently, Fractal Woman Lori Gardy says that he's trying to get it like patented or some mumbo jumbo. He doesn't want anybody to know what software is using. So the blue is compression, ether compression, and then this one is the now a wave of rarefaction, basically a void. So and basically this is, he's saying this is what radio waves are. And I do think this is right, just ether vibration. Okay, but the thing is, like, he has no discussion here, but like, why doesn't he just explain it? Like, okay, fundamentals of ether part 4, the VDO. I'll see what video he has here.
Hello everybody. It's been quite a while since I made a video like
Okay, but this guy, I definitely think he's onto something. And that's another part. It's like you can tell if somebody's on like knows stuff when he has not a spook, but when he has a lot of quirks. Like this guy, just give me the info. Like, what is everything's so hard. Okay, alternating current, continuous, and the other. Well, this is where I think MES stands out. Is like I understand the massiveness of this stuff. That's why I do these live streams open so everybody can see that we're all in the same mindset here. Bob Greener last live showed a Russian experiment debrief with a rotating disc changing the path of laser, essentially proof of ether disruption. Interesting. So we need to get that. And now I'm gonna get this as well. I'm gonna just put this in here. Meta. Okay, so we're gonna start feeding this. Radio disrupting ether makes a lot of sense. Yeah, so radio is just disturbance in the ether. It's nothing else. And then I think he calls magnetism as just like rotation of the ether. So then, but he's saying that there's no magnetic component in radio waves, and I think he's right. Yeah, so we'll get to that in a bit. And so I have the PDF I just downloaded. I'm gonna feed this in. Attach new document. Meta spectrum. Okay, I'm gonna attach the mechanical origins of electrostatic force. Okay, so we fed this one in there, and now I'll do a new conversation. The conversation's new. How do I do a new one? Like, how do I do anything? Okay, I think I click on this one. New conversation. Light has magnetic component. No, it can affect magnetism, but mainstream light has well, his thingy says it doesn't have it, and I think he's right. We'll explain it in a bit. I'll show you this right now. So light doesn't have a magnetic component. that's the breakthrough that I'm trying to argue based on his reasoning here. A fundamental theory of ether, and so think of it this way. He explains it right here. The mechanical origins. I'll open up in I'll open up as this thingy here. I'll open up directly in here. Triode amplifier and simple supercap with the casing as another terminal. I'm not sure what that means. It's like simplified. Yeah. So what I'm trying to say is, you can, according to his thing, because again, I think he's onto something. So basically, he's saying the demand. So if you go over to his paper, I might even. How much time we have? 12 minutes. I'll read as much as we can. So this work is okay. This is the fundamentals of a theory of ether, part 4, the mechanical origin of electrostatic force, the nature of electric field, radio waves, and light, a solution to the wave-particle duality, the propagation of light in channels, helping Millikan explain the photoelectric effect, or electrical science without positive and negative charges. Okay, there it is. He summarized it. Electrical science without positive and negative charges. So that is pretty much the name of the game. So can you remove those charges? What in the world are they? Abstract. This work is a further development of the ether that explains electrostatic attractions and repulsions by the molecular vibration of objects acting on another through the liquid ether that fills the vacuum and the interatomic spaces of substances. The 2,000-year-old problem of mechanical explanation of the laws of electrostatics is answered by the behavior of coupled oscillators. The physical origin of the electric field is that of a to and fro motions of the ether. Heavy side. Okay, don't remember. Yeah, I'm not sure what's going on. Anyways, this guy's Ainaldino. I think he's onto something. I shared a few of his videos on magnetism as rotation of the ether, which is pretty interesting. The physical origin of the electrical field is that of a to and fro motion of the ether. Light and radio waves are shown to be longitudinal waves consisting of to and fro motions of the ether along the direction of wave propagation, which makes them essentially electric waves. So it's not magnetic. So magnetic is rotation. Corroboration with the results from various previous works leads to the conclusion that the complete nature of light and radio waves is that of electrogravitational waves. The 100-year-old problems of the photoelectric effect and of the wave-particle duality are solved by uncovering the direct link between voltage and frequency of vibration by a new interpretation of de Broglie equation and by advancing the new theory of light propagation in channels. Yeah, this is pretty interesting. We'll go over here. I might keep reading this next week as well. Introduction, and then basically see if we can hammer down what's going on here. So introduction. This work claims to solve the 2,000-year problem of giving a mechanical explanation of electrostatic force. It is part of a broader project aimed at finding the mechanical explanation for all the interactions at a distance, gravitational, electrical, electrostatic, magnetic, as well as the propagation of light through the ether as a longitudinal wave. Explaining electrostatics mechanically has been known historically the most challenging of all the interactions at a distance, recognized as such by the scientists of the 19th century who were fully immersed in the experimentation and the mathematical representation of the phenomena of electrostatics and magnetism. One of them was William Thomas Lord Kelvin. The Kelvin guy. Although he is remembered today as the inventor of the scale of the absolute temperature, William Thomson's main line of work was in the field of electromagnetism. He contributed to the successful transmission of electro signals through the first transatlantic cables that linked Europe and America. William Thomson was contemporary with the likes of Stokes, Joule, Maxwell, and Heaviside, whose works he followed, understood as he did the works of Faraday and Green, who preceded him. He invented important instruments for the measurement of electrical quantities and was involved in the setting up of the electrical units of measure used today in electricity and magnetism. His positioning in the midst of the scientific activities, both experimental and theoretical, that took place in the second half of the 19th century and contributed to the development of electricity and magnetism makes his opinions and thoughts extremely important. Relevant to the present work is William Thomson's recognition in his 1889 address, Ether, Electricity, and Ponderable Matter, of the necessity of a mechanical theory of electric and magnetic interactions. And this is the Kelvin guy, Lord Kelvin. Was William Thomas Lord Kelvin. Is that what he says? William Thomson. Why is it Thomson? Lord Kelvin. What's Kelvin coming up for? Wiki. Is that his title? The sunlight must interact with the Earth as voltage and frequency increase with nonlinear chaos later increased probability of electron teleportation across. Again, he has any evidence of light having magnetic properties. I know some people can see magnetism. Yeah, so again, it's like seeing are they just seeing interaction with things. Okay, so William Thomson, he's called as Lord Kelvin. First Baron Kelvin. Okay, he's got some magical names. Okay, so he's got some Illuminati big names. Anyways, okay, let's go back right here. So he wrote, the demand for something like a mechanical explanation of electrical phenomena is not new, but is growing intensity every year. A remarkable thought of William Thomson is his hopelessness that he will ever be able to find a mechanical explanation of electrostatic phenomena. No, it's probably Freemasonic, i.e. cathode ray tube. No, I think this guy explains cathode ray tube. You're just saying things like basically, Elijah, you have to you're saying things as if saying that the only possible explanation is the like the one that you're having in mind. Like you can interpret it, different experiments using any type of interpretation, but then the question is which one's the most accurate and how do you confirm what is what. So that's kind of what I mean. Anyways, a remarkable thought of William Thomson is his hopelessness that you'll ever find a mechanical explanation of electro theater. Now, with reference to the electrostatic effect, the hopeless, I must not say hopeless, that is too large a word. We are never without hope in science. I was going to use another word, despair. Well, I feel it desperately difficult. I feel the probability of my seeing the solution of it is hopeless. And he's probably illuminating some information and not a lot to know. This is probably saying like, I want to tell you guys, but I'm given a title Lord Kelvin. He's given a title Lord Kelvin. And he's like, I ain't touching my money gravy train right here. It's like they're gonna name temperature after me, and I ain't telling y'all. Anyways, that's me putting my insights on this Illuminati insights. British Association of Advanced Scientific Reports on the Committee on Electrical Standards, a record of history of absolute units, and Lord Kelvin's. Anyways, that's stuff there. 1890. Anyways, and again, this is 1890s. The summit I've absolutely not ignored because I have spoken of it 2 or 3 times, but I left it out in the cold. The electrostatic part, the thing we knew first. Our first love was electrostatics. That is absolutely left out in the cold, electrostatic cold. We do not touch it again. Cold fusion. We do not get near to explaining the mutual force between two electrified bodies. I'm getting a message right here somewhere. Where's my phone? Okay. Yeah. So yeah. So it's just, again. I've absolutely not ignored, because I have spoken of it 2 or 3 times, but I left out in the cold electrostatic part. The thing we knew first, our first level was electrostatics. That is absolutely left out in the cold. We do not touch it. We do not get near to explaining the mutual force between two electrified bodies in any of these illustrations or attempted explanations. So in other words, Lord Kelvin is literally saying we do not touch electrostatics, the actual explanation of it, besides saying positive negative charge, because that's a Illuminati top level secrets. All right. Anyways. The illustrations or attempted explanations William Thomson was referring to in the above quote were mostly related to the magnetic effect of the electric current. So magnetic effect of electric current, yeah, again, when you have passive current through, it creates a magnetic field. In other words, just rotation in ether, for which a mechanical explanation has been pressed in the series of works titled Fundaments of a Theory of Ether. Although the knowledge of fluid mechanics was relatively well developed in William Thomson's time, the fact that the nature of the electric current was not well understood prevented everyone from observing that an electrical current in the nature of surface waves along a conductor would generate the required circulation of ether surrounding the conductor, which ether circulation many thought constituted the magnetic field that the current produced. So yeah, basically, if you have current through, this is alternating current going back and forth. I think it's got to be a different way. But yeah, basically, if you have current going in, it spins the ether, and that's the magnetic field. So magnetic field is just ether rotation when you have current going. That's according to this guy, and I think he's right. Anyways, okay, so going back here. Perhaps the closest to this theory came the description of the propagation of electricity in the wire as similar to the propagation of sound through an elastic body, or propagation of motion through a series of ivory balls. In connection with the magnetic effect of the electric current, it is interesting to mention here William Thomson's strong belief that in the interior of a current-carrying solenoid, the ether rotates continuously or through a definite angle. He could not tell which of these two actually occurred. The amount of rotation depending on the strength of the current. I must note before we look at this quote that I consider quite unreasonable William Thomson's assumption that the ether had rotational rigidity and that the electrical field lines drags the ether. Electric fluid drags the ether. The Swatska is actually the magnetic field from scalar wave collapse. Interesting. Okay, then we're going to talk about scalar waves. Again, before we get to that, because I think that's probably just a different mode of the ether, and so on, what people call scalar. Again, everything is ether. Just think of that, and then basically build upon that through experiments. Experiment, guys. It's like, yeah, I almost blew up my eardrums. Experimenting, but I should have studied a bit more. Anyways. So imagine this, figure 2 or 3 to be the section of an ordinary helix. This is ordinary helix. Okay, yeah, this is a solenoid, basically rotating. Or solenoid with a copper core. Yeah, this is a copper core. Oh, no, current is going continuous. Yeah, basically you have a core right here, and then you have current going around it. Imagine a continuous electrical current, or electrical and figure... this is alternating, going around, back, around, back, around, back. Okay, he's loading up YouTube. Getting his messages right here. Oh my goodness, it's gone. Okay, anyways. I'm gonna also charge my thing. He's charging. It's done charging. Okay, imagine this would be the section of ordinary helix solenoid with a solid copper core. Imagine a continuous current and then going out, or an alternating current electron. And this, this goes, basically alternating interior. Anyways, so he says here. Electricity through the solenoid shown in section by the outer circle, whatever. And this way, again, papers, books, like articles. This needs to be a video, not a little thingy. But I think he has some videos on this. Whatever the current of electricity may be, I believe this is reality. It pulls the ether round with a solenoid. So he's thinking that it has some rotational rigidity. I do not think this is a dream of electromagnetic theory. Difficult as that is, I believe it to be reality. Whatever ether is, we move through it. The Earth moves through it. Somehow or another, however, it is the ether pulled round. The ether does get a turning motion in the interior of a solenoid. Somehow or other, the electrical current through the surrounding wire does give a turning motion to either in our supposed copper core and in the air between it and the wire through the current which is flowing. And now instead of an alternating current through the helix, take a constant current through it. What can it do? One thing or the other. It does either a constant current through its this helix drags the ether round and around inside, or drags it round to a certain angle proportionate to the strength of the electrical current, and brings it to a static equilibrium. So turned. So it does either one or it does either one or other of these things. I will end this rather historically centered introduction with a prophecy William Thomson made at the end of his 1889 address on topic of a mechanical theory of electricity and magnetism, and with my comment that the present work might be the fulfillment of his prophecy. Anyways, prophecy, and then he's saying that he fulfilled it. And this is why I think he's onto something big, is Arnold Dino does understand that this is pretty big, and he's putting himself in this prophecy mumbo jumbo. And here I'm afraid I must end by saying that the difficulties are so great in the way of forming anything like a comprehensive theory that we cannot even imagine a finger post pointing to a way that can lead us towards explanation. That is not putting it too strongly. I only say we cannot now imagine it. Again, he's got some Illuminati knowledge that nobody's going to know but what electric charges are for a century. But this time next year, this time 10 years, this time 100 years, probably it will be just as easy to as we think it, as to understand that the glass of water, which now seems so plain and simple, I cannot doubt, but that these things which now seem so to us so mysterious will be no mysteries at all. That the scales will fall from our eyes, that we shall learn to look on things in a different way. When that which is now a difficulty will be the only common sense and intelligible way of looking at the subject. I ask you to pardon me for leaving you up to so impotent a conclusion that we really know nothing below the surface of this grand subject which constitutes the province of the institution of electrical engineers. So anyways, he understood. Lord Kelvin knew that nobody knows anything about electricity, even by electrical engineers. In this year, the year 2024, this time 100. This time 100 years, William Thomson prophesied in his 1889 address quoted above. No, is this year the year 2024? And is the present work, albeit 35 years later from the 100 years, prophesied, going to be the one showing how to look on things in a different way? The only common sense and intelligible way of looking at the subject of electrostatics. I can only hope that what follows will, in William Thomson's words, make the scales fall from our eyes. Okay, we got some epic stuff here, and we'll be going over this. I'll finish this paper next time, or continue it in the next stream, guys. It's very epic stuff. Some believe ether is God as an interaction with each unique situation in kind. Well, yeah, that is interesting, guys. Ether is an anagram of father. So father, ether, earth. So I've typed some stuff over here. We'll go into peak right here. The reality is displacement current, density, and heavy side drive your electrical current. Yeah, but I'm trying to tell like mechanics. Like speak to me as if I'm a I'm just like can you replicate your thingy in an experiment, like a mechanical experiment? Make an analogy of exactly what you said. For example, here's the peak experiments. So this is the Einaldino guy. Is this guy? Einaldino literally developed this. He shows that if you have two rotating cylinders, if they rotate the opposite directions, they attract. If they rotate, if they rotate this opposite, and they attract. And if they, this is opposite as well. This is rotating this way. The other one's rotating this way, and then they attract. Yeah, this is basically if they line up, they attract. If they if they repel each other is when their like charges repel. So this is spinning the same way, and then because if you invert them towards each other, it becomes opposite. If they're the same, yeah. So the same, yeah. So basically, this repulsion is this ether rotation, and exactly the same setup here. This north, and so if you can explain poles by fluid rotation. Just that's a great analogy of that. And again, that's this guy, Einaldino, is the one with the paper. And I'll go over the paper next Wednesday because I was gonna go over it eventually, but I think it's good on these streams because we can all get your input and so on. And also, yeah, going back to the thingy. I'll zoom this in bigger. So ether. So ether. Now, if you have father, so again, like God the Father, it's literally like the anagram of ether. And you have earth, it's anagram of ether. And we have everything's got that. And then even the most used word ever is the and a is ether. The most used words are the A, yes. The or the A, ether. It's like everything is ether. And what else did I have in here? Anti-gravity. Everything's ether. I had some more stuff here. Even mother is ether. Let's go. Even mother. Yeah. So, I think I had ether, mother. Yeah. So ether. Um. Okay. This is ripple and ether. I think I had a bunch here. No. Yeah. Because again, gyroscope's literally. Okay. Let's go back here. Okay. Where's the other ether? Oh yeah, death. Just so we have death. Ether, father, earth, the, death. It's like EATH. Everything is there. Mother. Mother is like over there instead of but it's very very close there. It's I think that was something like that. I think. What was the exact reasoning? Mother's it's close enough. Earth, theater, ether, reality. Yeah, and then breath and then breathing. So breath. Mother is an okay one. Breath. So we have breath or breathing. Breath, breathing. Yeah. Breathe. So we have breath, breathing. Everything's ether. Breathing, earth, father. Okay, and then I think we had some other stuff. Breathe. Yeah. Okay, and then yeah. Anyways, so again we're on some wild stuff. Yeah, I'll highlight all these. I'll put on. Yeah. Anyways, we're done with the stream. Oh, I'll actually end this right here. I'll put that here. Force alignments is a synthetic biology and lattice confinement. Again, some people believe ether is God. Yeah, and then the AE. Notice the AE together. AE together is the big one. A together is just the 6-9 as above so below. It's like everything is intertwined in this moment jumbo. And then the AE and also like that's a lot of Illuminati people use that AE. AE. Let's go AE symbol. Oh, you got American Eagle. That's why it's called American Eagle. And there's the AE character. AE, yeah, like that, or AE like that. Yeah, you got a whole bunch of jazz in here. Yeah, so Aether, and then you got whoops, and this is the old one, Ether. So again, it's like the AE is gone. Yeah, so this is quite wild stuff here. I'm gonna go and also I posted this one right here. I'll edit this. Okay, so we are wild and okay, guys. It's epic stuff there. And AE, there's also a big company, AE company. Yeah, it's like they had to remove this. Associated engineering, interesting. Associated engineering. Why would they put the A there? AE logo. I think that has a bunch of images on here. Images. AE Corporation. AE. This is Ether Corporation. Okay. AE. Architects and engineers. Architects. AE 911 Truth. Architects and engineers. So the clowns are all just stealing our names. Decoding symbols is very important in this understanding. Yeah, it is. And it is and isn't. Basically, what I'm trying to say is, the more in sync you are with reality, numbers, patterns, they just show up on its own. That's what I mean by it isn't. It is, but you'll be able to find more numbers the closer you are to reality. So in other words, you have to be able to get it, you need to create some anti-gravity. So if you were producing some anti-gravity live to the world, like do a live stream to the world, it means your knowledge of patterns will also skyrocket as well. Okay, Gonzo, there are 13,339 words of AE in English. Interesting. Yeah, I'm talking about the most used ones. Like like most used ones, the and A is like the most used words ever. You can go here, the most used words in English is the and A. And then also like earth, ether. No, yeah, earth is like you live on earth. So I'm not getting some random words, like some random object, like some random bird or whatever. I'm talking about like literally the biggest common ones. Yeah, so the and A are the most commonly used words in English. Like that's why I'm saying these are the most common. Yes, the is the most common used words, and A is also among the most frequent, and so on. There should be a chart here. Okay, those are the letters, but there should be like a giant most frequent words in there. Anyways, that you could check it for another day. Yeah, so that's kind of what I mean. Like, we're not talking about every word. Okay, best words list. Best words with list. AE. Arrow states. Yeah, yeah. AE. And I hate how they removed it. They should have just kept it together. They should just put it together. Like ether. Like then the what is that? Yin yang. Yin yang is literally just AE. So yin yang symbol, yeah, so A is basically the A and the E, but it's reversed. So we got the reverse direction. Yeah, this is good one. You have A, E. Anyways, we're all welding, guys. That's all for today, guys. Friction is key to ether interaction along with hydrogen. Okay, anyways, we'll go over here. We'll go to page 6. This is gonna be pretty epic. And so again, ether, yeah, radio waves are just vibration. Actually, we haven't even got to that. I'll show you. He did a demonstration of this. So if we go into here, here's radio waves. If you have just, so if you have, here's just, we'll call that electrogen or electrons, whatever, going back and forth, or charges going back and forth, you have radio waves in this fluid ether. So you vibrate it, you literally get these sound across. So that's kind of what I mean by, it's kind of what I mean by there's no magnetic component, but it can interact with magnets and so on, because magnets would be rotation. This is just the vibration going all the way across. And everything's just ether vibration. Everything's just different modes of the ether. So magnetism, yeah, technically, yeah, light would have magnetism, but that's just rotation. But this is just vibrating, and you can interact with rotational things. In other words, it can interact with heart too. Okay, for heart and arrow. Okay, Gonzo just dropped some bombs here. Heart and arrow. Okay, so we got heart as well. So anyways, I care about the big ones. Those are the big words I care about. And arrow, aerospace, air. Okay, so we have ether is arrow. Why does it keep doing that there? Okay, this is gonna be, yeah, I'll type it in here. Heart, arrow, arrow, dynamic, etc. Aereo. Okay, but anyways, we'll keep that. I'll just keep it arrow. All right, so we're good to go, guys. Why does it keep saying this draft thing? Okay. That is all for today, guys. Thanks for joining, and have a good day. And I'll close some stuff here because John's sending me some jazz. All right. Anyways, and this thing's pretty cool. So I'm gonna have anything that I put in here will be basically we're gonna use AI to take over the world. Tesla said ether is very dense, counterintuitive, but explains behavior. Yeah. It's the other part is again. I was gonna make a video about him, but I think I just want to do like one experiment at a time. Also, rotation, like spinning and wave patterns, are the same depending on their favorite reference points of dimensions. Interesting, yeah, that's a good point. But anyways, that's why I try to go slow, one experiment at a time, so we are all on the same page and we can rule things out and or keep it for future. Anyways, so and I'll share this. This is the full project. How do I share this project? Okay, allow anyone access. Okay, anyone can access this. Okay, so anyone can access, guys. You guys can all access my full project here, and it's gonna be an epic project there. I'll go to in Leo and then I think we have it here. Let's put it here. Yeah, so we're pretty much done. We're just on last. Okay. Yeah, so there's the full grok and attachment, everything you guys can access and so on, and this right here. Maybe it's 4H hydrogen not club. Okay, anyways, yeah. So definitely read that book, Fundamentals of a Theory. There, we'll read this as well as I go through, and so on. This is again, it's gonna be absolutely bombshell. I'll post the last one. Okay. Where's the put this in here as well, just for future sakes. All right. That is all, guys. All right. Thanks for joining. Yeah, thanks for joining, and have a great day, y'all. Okay, we are adiosing. And also, Gonzo is prime real estate on Rumble, taking over the game. Epic stuff. Okay, have a good one, guys. Ending the stream in 3, 2, 1. End stream.